Hello everyone, in this video we are going to learn gravitation for KCET, JEE and NEET. So first we are starting from the Kepler's law of planetary motion. Kepler's gave three laws of planetary motion. First law is also called as what? Law of period. What Kepler's told? Kepler's told that any planet revolve around the sun in elliptical path with the sun at one of its foci. Okay, it means here P is what? Planet, and S is the sun. Where is the location of sun? Sun is present at one of the foci of the ellipse. Okay, and planet is revolving in elliptical path. Okay, this is called as what? A law of period. First law is also called as what? A law of period. Okay, when we talk about the second law, that is called as law of area. The line, what he told, the line joining sun to the planet. Okay, here P is the planet. P is the planet which is revolving in the elliptical path. The line joining sun to the planets sweeps out equal area in equal interval of time. Okay, so let's take the planet is moving from A to B in time t. Okay, so this area A1 is there. This area swept is what? A1. At the same time in time t, it is moving from C to D. Okay, so area covered is what? A2. So A1 will be equal to A2. Another statement is there, that is aerial velocity is constant. Okay, aerial velocity means dA by dt is constant. How is this possible? What happens whenever planet is near to the sun, means whenever the radius, if you see the radius distance is less, at that time velocity is more. Whenever planet moves away from the sun, whenever it is at a far distance from the sun, okay, so what happens here? Velocity decreases. That's why area covered will be, you can see this will be the area covered. So overall area A1, A2 will be same. Another statement we can write dA by dt is equal to L by 2m. This also may be important. Okay, so we can write here, if RA is the distance, this is the RA distance. Okay, if this is less than RB, RB is the distance of planet P from the sun. Okay, so what will happen at 8 point? Velocity will be more than velocity at C, you can take. Okay, instead of B you can take C. This point is C. Okay, na? So if RA is less than RC, this is RC actually. You can take, this is RC. This is RC actually. Okay, so if this RA is less than RC, then velocity at A will be more than velocity at C. Understood? Next, third law, that is called as law of period. Okay, according to this law, the square of time period of revolution of the planet is directly proportional to the cube of semi-major axis. Okay, T is the time period of the planet, A is what? A semi-major axis. You know about the ellipse, right? So this is the ellipse. Here this is the major axis. A is what? A semi-major axis. This is what? A semi-minor axis 2B. So this point is B and this point is, this distance is also B. Yes or no? So this is Kepler's three laws of planetary motion. I hope you understood these concepts. Next we talk about universal law of gravitation. Okay, what he told, whenever two bodies are there in the universe, M1 M2, separated by distance r, so there exists a force between them. That force is directly proportional to M1 M2, product of the masses, and inversely proportional to the square of distance between them. So once you combine, we can write F directly proportional to M1 M2 upon r square. Yes or no? Once you remove the proportionality, you have to put a constant. That constant is what? G. So F is equal to what? G M1 M2 by r square, where G is what? Universal gravitational constant. Okay, what is the value of G? 6.67 into 10 power minus 11 Newton meter square per kg square. They may ask you the dimensional formula also. Dimensional formula of G is what? From here we can write G is equal to what? Fr square by M1 M2. So substitute the dimensional formulas of all. You will get M to the power minus 1, L to the power 3, T to the power minus 2. Substitute the dimensional formula for F. Okay, distance square and mass. You will get this. Next, relationship between a small g and capital G. The relationship is there, that you have to remember. Small g is equal to capital G, capital M by r square. If you substitute the value of capital G, M, capital M is what? Mass of the earth, R is what? Radius of the earth. What is the radius of the earth? 6400 kilometer. If you substitute all these values, you will get G value as 9.8 meter per second square. In meter we can write this one 6.4 into 10 power 3 and 10 power 3 becomes 10 power 6 meter. Is it clear? Now let's talk about the variation of G. G, okay, varies with the height, depth, with rotation, with shape. So first is with height. Okay, when you move away from the surface of the earth, okay, and let's take earth is there, and at height h from the ground, from the surface h is there. Okay, you know G at surface is what? 9.8. But when you move away from the surface, okay, so GH is equal to what? G times of 1 minus 2h by r. This is here condition is what? The h is far less than r. Okay, r is what? Radius of the earth. When h is far less than r, means for a very short height, like 10 kilometer, 15 kilometer, 20 kilometer. Okay, and what is r? R is 6400 kilometer. Yes or no? So we can write this formula, we can use this formula, GH is equal to G times of 1 minus 2h by r. And from here we can see 1 minus something is what? Less than 1. So with height, when h increases, acceleration due to gravity decreases. Similarly with depth also, G decreases. Okay, we have an expression, G at depth is equal to G times of 1 minus d by r. Okay, you can see again this term 1 minus something is what? Less than 1, yes or no? So G will, when depth increases, okay, G decreases. Means when you go towards the center of the earth, down, okay, so value of acceleration due to gravity decreases. Next, with the rotation of the earth, okay, so G alpha is equal to G minus r omega square cos square phi. G at phi is what? Angle. Okay, latitude, this is latitude angle. Omega is what? Angular velocity. Okay, when we see, when the phi is at equator, phi is what? 0 degree, equatorial plane. Okay, we talk about here equator, this one, at this point. Okay, this is the equator line right now. So here what is the value of phi? Phi is what? 0 degree. If you substitute the value of 0, cos 0 is what? 1. So we will get G at equator is G minus r omega square. Whereas when we talk about the pole, okay, this is the polar regions right now. So at polar region, what is this angle? You can see this angle is how much? Phi is equal to 90 degree. So cos 90 is what? 0. So we will get substitute the value. Okay, G at equator is equal to G we will get. Okay, or otherwise we can say due to the shape of the earth, from the expression what we learnt, small g is equal to capital G capital M by r square. Okay, as capital G is constant, M is constant, but radius of earth is not constant. Generally what happens, radius of earth is more than radius of pole. Okay, the shape of earth is not perfectly a sphere, it is a spheroidal, like this you can see. So in this what happens, radius of equator is slightly more than radius of pole. Okay, so as you know that G is inversely proportional to the radius square. So as the radius of equator is more than radius of pole, so G at equator is less than G at poles. This is very important concepts. They may ask you the questions based on the graph. This question, okay, so here this is the r, that is the distance from the center actually. Okay, and this is this side of y-axis is what? Acceleration due to gravity. Okay, let's see what is the value of G at the center. At the center, what is the value of D? Okay, D is what? 0. So we know that G at depth is equal to G times of 1 minus d by r. At the center, D is equal to what? R. Okay, D is equal to what? R. Yes or no? Now substitute the value, G at depth is equal to G times of 1 minus r by r. So you will get 1 minus 1 is what? 0. So G at center is what? 0. Remember this point, acceleration due to gravity at the center of the earth is what? 0. Okay, so that this is 0 only. On the surface, what is the value? 9.8. It is maximum at the surface, yes or no? Correct now, as you know that as you go down, so G decreases, it will come to 0 at the center. Now again, when you move away from the surface of the earth, G values decreases right now. So actually what is happening, from 0 to okay, from the center to the radius, okay, it is first increasing, yes or no, and if you move away from the surface it will decrease. So graph is like this. This graph is very important. Okay, first it is increasing 0 to r, then it decreasing. Okay, next concepts are orbital velocity. What is orbital velocity? The velocity acquired by the acquired by the satellite to revolve around the planet. Okay, here let's take a P is the planet which is revolving around the Earth. Let's say this is Earth is there. Okay, satellite is there. S is what? Satellite. Okay, here it is what? A satellite. Satellite is revolving around the Earth. What do you mean by satellite? Satellites is nothing but a celestial body or an object, okay, which revolve around a planet is called a satellite. Yes or no? So here satellite is there which is at height h. So it is revolving around the Earth. So orbital velocity, you should remember v naught, okay, is equal to square root of gm by r. Okay, where g is what? Capital G is what? Universal gravitational constant. M is the mass of the planet, we can say, or mass of the Earth here in this case. Okay. Now what happens for any satellite which is revolving close to the surface of Earth, okay, means a height, okay, this height is very less compared to the radius. So we can write this small r is nothing but capital R plus h, that is a small r, you can see. So for any satellite which is revolving close to the surface of the Earth, what we can say, v naught is equal to root under gm by r. Okay, because r, this small r is equal to r plus h. If h is far less than r, so we can write r is approximately equal to, small r is approximately equal to capital R. So we can write v naught is equal to gm by r. Yes or no? If you substitute the value of capital G, capital M and a small r, you will get v naught. Okay, v naught value is what? 7.9 km per second. Okay, for any satellite to revolve around the Earth, it should revolve at what velocity? 7.9 km per second. In 1 second, it should travel how much? Approximately 8 km. Yes or no? Now time period of satellite. When we talk about the time period of satellite, how do you find the time period? Total distance traveled by velocity. Yes or no? So total distance traveled is what? 2 pi r. Okay, total distance is nothing but the circumference of the path. Okay, now so 2 pi r divided by orbital velocity. Substitute the value, you will get 2 pi r by square root of gm by r. Okay, move it up, we get 2 pi square root of r cube by gm. Okay, this is the expression for time period of a satellite. Okay, what is m? M is the mass of the Earth, r is the radius of the Earth, h is the height of the satellite. You should remember the energy of the satellite. Okay, so kinetic energy is there, half of g mm by r. Capital G is what? Mass of the Earth. Small m is what? Mass of the satellite. Small m, mass of the satellite. Mass of the satellite. And it will have potential energy, that is minus gm by r. R is the distance from the center of the Earth. And total energy is what? Minus gmm by 2r. Actually total energy is what? Negative of kinetic energy. Total energy is what? Sum of kinetic energy plus potential energy. Now let's talk about geostationary satellite. There are two types of satellite, geostationary and polar satellite. Geostationary means what? It will be stationary with respect to Earth. Means it will rotate like this, you see. Suppose this is the Earth and the satellite is there. Okay, how it is revolving? It is revolving along the equatorial axis like this. It will revolve like this. Okay, so it will be at rest with respect to Earth. Okay, so what should be the radius? Okay, distance, how much distance should be there? Approximately 4.22 into 10 power 4. Okay, this is what? 10 power 4 kilometer. 10 power 4 kilometer. Okay, and what is the time period of geostationary satellite? 24 hour. It means to complete one cycle it will take 24 hour. Where we are using geostationary, it is used for communication purpose, telecommunication purpose. Similarly, we have a polar satellite. Polar satellite, okay, it will revolve around the polar axis like this. Satellite will revolve. Okay, so it should be at a height of how much? Of 500 to 800 kilometer approximately. Time period of such satellites, polar satellites, are approximately 100 minutes. Where we are using it is used for navigation purpose, GPS tracking. Next we talk about escape velocity. Escape velocity is the velocity, okay, with which a particle is thrown from the surface of the planet so that it will escape the gravitational pull and it will never return back to the planet. Yes or no? So here escape velocity is what? Square root of 2 gm by r. Okay, generally if you substitute the value of we know that small g is equal to what? Capital G capital M by r square. So from here we can write a g r square is equal to capital G capital M. Substitute the value, you will get a escape velocity as square root of 2 gr. Okay, so generally escape velocity is what? Root 2 times of orbital velocity. Okay, it is approximately 11.2 kilometer per second. Escape velocity on the moon is how much? 2.3 kilometer per second approximately. It is very less. Okay, so that's why there is no atmosphere on the surface of moon. Whereas on the sun, escape velocity is what? Approximately 42 kilometer per second. Okay, I tried to cover almost all important concepts of gravitation. I hope you understood these concepts. Please just share this video with your friends and don't forget to subscribe the channel. Here admission is open for the crash courses, okay, of KCET, JEE NEET, even for the academic session 2026-27. If any of you are looking for admission offline classes, you can join at Hoyshala Circle branch, Kengeri Satellite Town. You can contact me at this number 8050644272. Thank you.